Assalamualaikum and good morning. So today we will discuss tutorial for centrifugal pump. So we go for question number 2. Centrifugal pump has inlet and outlet diameter of 30 centimeters and 60 centimeters respectively. Impeller width at outlet is 12 centimeters. Blade thickness occupy 10% of the circumference. So blade is backward with inlet and outlet blade angle is 30 and 40 degrees respectively. The flow rate is 0.5 meter cube per second. Assume there are no whirl at inlet and velocity flow is constant. Okay, so in this question, you have a condition where the blade thickness occupy 10% of the circumference. So okay, this statement is actually refers to the equation of VF Q over K pi D and B. So and then if you read this sentence means 10% of the total area is actually the blade. So means that water only can go through 90% from the total cross-section area. So and then in this case we could take the value of K is 0.9. Okay, means that you need to really understand the sentence, the statement, and then you convert into the value of K. Please do not simply take the value of K as 0.1 because 10% is 0.1. Okay, you need to understand what is the function, what is the meaning of K, and what is the meaning of this statement. So and then it gives you a backward in blade here, and then they give you another statement which is there are no whirl at inlet. So when it says that there is no whirl at inlet, so it means that the V whirl 1 is equal to 0. So means you need to draw your velocity triangle slightly different from compared with question number 1. Okay, and then the flow velocity is constant. So the statement of flow velocity is constant means that the velocity of flow F1 will be equal to VF2. And sometimes you could use just VF only. So it is okay for you not to mention whether it is inlet or outlet because the velocity of flow VF is constant. So means inlet and outlet will have same velocity of flow. Okay, so and then from this question, we need to determine the rotation of pump in RPM, the output power if manometric efficiency is 85% and the pressure different across the impeller. So we will see the solution of this. Okay, first you need to draw your velocity triangle. Okay, this is the rotation direction, and then if you stay here, so you are look forward like that, you will find that this blade is actually at your back. So we call this blade is a backward blade. So this is the common simple tricks for you to understand to draw the backward blade. Okay, and then you need to draw your velocity triangle. So this is the velocity triangle for inlet, and this is the velocity triangle for outlet. So this is the angle here. So 30 degree here, it will be equal to here, and this 40 degree. Okay, so it will equal to this one. Okay, and then for inlet, it is state that V whirl 1 is equal to 0. So means that the V1 here, the actual velocity will flow in radial direction. So now we could write down V1 equal to VF1. So and then we list down all the parameters stated in the question. So all of this is for inlet here. So we have a D1 is 30 centimeter, D2 is 60 centimeters, so B1 is 12 centimeters, and then we have the value of K, which is 0.9. Okay, so after you list all the parameters and then you draw your velocity triangle as shown in this figure. Okay, So we may start our calculation. So the first question is we need to calculate the rotational speed for the pump. So this is a quite straightforward question, because if you look all the equation, there is only one equation which has the value of n. So that equation is u. So u equal pi dn over 60, like this. So and then you have two options. You may write u1 and u2. If you write u2, you need to write pi d2n over 60. So you have this equation and also this equation. But you must make sure that all the parameter was given, and then you could use all the parameter to answer that question. So here we found that maybe it is advantage for us to use the parameter at inlet, because we have D1, we have B1. So means that, let's say we use a parameter for inlet, so we write as U1 equal pi D1n over 60, and then we rearrange the equation so we could calculate the value of RPM by using the idea of 60 times U1 over pi D1. Okay, so the problem is we don't know the value of U1. Okay, it is okay. So means now we need to calculate what is the value of U1. Okay, so this is the U1 component velocity, and we have this triangle. So the angle here is 30. So means it is very simple. If we could get the value of VF, and we could do something with this 30° to get the value of U1. Okay, so here there are no specific equation like I say before, because you need to solve all the problems based on your velocity triangle. Okay, so from this velocity triangle, so VF1 here is quite simple, because VF1 or VF here, it has its own equation. Okay, please remember there is only two equation that you need to remember. One is U and another one is VF. So and then another equation is actually developed from your velocity triangle. So and then VF is equal Q over K pi D2B2. So and then you could substitute all the parameter here, all the value, and then you get the VF is equal to 2.459 meter per square. Okay, this calculation is at outlet. Okay, however, because we have a statement of velocity of flow is constant, so we assume that VF2 is equal to VF1, or we could use just VF. Okay, so means that 2.459 is actually the value of V1. So I think you have idea to solve this problem by using trigonometry. Okay, so we could say that tangent beta or tangent 30° is equal to VF over U1. Then we could calculate the value of U1, which is 4.254 meter per second. So and then we substitute into this equation, we could get it is around 2.71 it is 271 RPM. Okay, I would like to advise you here, if you have decimal point in RPM, please round up the value. So round up mean you take the next numbers. So for example, you have 270.2. So please round up it into 271 RPM. So normally, if we have a lower value like this, 0.2, it is okay for you to round up to 271. So in your scheme, in your answer sheet, okay, when you answer this question, please first write down your final answer here, and then you just write that you round up the value of RPM into 271 RPM. Okay, this is for the first question about the RPM, and then we move for the second one. So output power if manometric efficiency is 85%. So the question want us to define, to calculate the output power. So we know that the V1 is equal to 0. So and then the output power means it is rho GQHM. Okay. Okay, please make some revision about the efficiency. Okay, so according to the manometric efficiency here, so this is the manometric efficiency 0.85, mean 85%. And this is the equation for manometric efficiency. And then because the V1 here is equal to 0, so we could neglect this term. And finally, we could have this one. Okay, to solve this problem, okay, we need to calculate what is V2 and what is U2, because the value of HM, I think, is already given in the question. Uh, I'm not sure here. Okay, it might be we need to calculate it. Okay. Okay, I'm sorry. So we need to calculate the U2 and V2. So and then if we get these two, U2 and V2, we could get the value of HM because the value of manometric efficiency is already given. Okay. So now, as I said, for U2, so we could straightforward use the equation. So the equation is U2 equal pi D2N over 60. So we substitute all the value here. So we get it is 8.514 meter per second. So and then we need to calculate the value of V2. So to get the value of V2, we could again look to our velocity triangle. So we have a 40-degree here. So means so we also have the same degree at this one. So and then we could say that the tangent of 40 is actually the VF2 here. So we have a VF2 here divided by the area of this one, the length of this one. So it is equal to U2 minus V2. So and then if you rearrange this equation, you could get something like this. So and then you could substitute all the parameters. You will get the value of V2 is equal to 5.587 meter per second. So and then you substitute everything into this equation. So this equation actually comes from the previous equation here. So you rearrange this equation to get the value of manometric head. So we could get the manometric head here as 4.12 meters. So and then we calculate the power output. So this is the equation for power, rho GQH. And if we use HM, manometric head, means the actual head that can be delivered by the pump. So means that is the power output, the final product, the final outcome of that pump. So we substitute the value of HM here. So we get the output power of that pump is 20.21 kilowatt. Okay, and then we go for the third question here, the pressure difference across the impeller. So you must understand the word pressure difference across the impeller. So we have a pump here. So this is inlet, this is outlet. So actually the real meaning of pressure difference across the impeller is actually we have blade here. So and then we need to calculate the value of pressure at inlet and pressure at outlet. So however, sometimes it is okay for us to simplify this one by measuring the pressure at point 1 here, the pressure at inlet here, and the pressure at outlet here. Okay. So let's say we use the idea of this one. So we use Bernoulli equation. So we have point 1 here, so we have point 2 as outlet here. Okay, and then we could write Bernoulli equation as this one, P over rho G, V square 2G plus Z plus Euler head. Why we use Euler head? Because Euler head is actually head that occur from point 1 to point 2 here. Head that occur inside the pump. Okay, so because we are only measuring point number 1 and point number 2. Okay, so that so means that the head is occur here is actually the pump head that occur inside the pump. So that head is Euler head. Okay, and then another thing that you should know is the value of V1 here and V2 here is actually the actual velocity. This is actual. So this is also the actual velocity. So means that from the velocity triangle, you only can use the value of V1 and V2. You cannot use another component because you know component velocity means just velocity that a part of that real velocity of that resultant velocity. So you cannot use component velocity into the Bernoulli equation. You need to use actual velocity. So means here you need to calculate, you need to know what is the value of V1 and what is the value of V2 to be substituted in the Bernoulli equation. Okay. Okay, let's say, and then, okay, so we try to fulfill this Bernoulli equation. Okay, what the question asks to calculate the pressure difference. So means that the value of P here will not know. So we need to calculate the value of P2 minus P1. So means that we need to know what is the value of velocity, what is the value of Euler head. Okay, so and then we could neglect the value of Z1 and Z2 because if our pump is like this, okay, we could assume that the level of point 1 and level of point 2 here is equal. So we could cancel the value of Z1 and Z2. Okay, we could calculate the value of Euler head by using manometric efficiency. So from the previous question, we know that the manometric efficiency is 0.85. So the equation for manometric efficiency is this one. And then we could cancel off the value of rho GQ. So we have HM over HE, and then we could calculate the value of HE is equal 4.847 meters. So, and then we need to calculate the value of V1 and V2. Okay, as I said previously, we need to use the actual velocity to be substituted in Bernoulli equation. So means that from this velocity triangle, for the first one, it's quite easy because the V1 is equal to VF1. So means we are simply could write V1 square is equal to VF square, and then it is equal to 6.032. So why I calculate this one in terms of V square? Because in Bernoulli equation, we will use V square. It is okay for you to get the value only V1, and then you times you make it square in the Bernoulli equation. So it is okay. So and then, so the problem is how to calculate, how to get the value of V2. As I said, you need to solve, you need to find your own ways, your own method by using trigonometry and so on and so forth to calculate, to get the value of V2. Okay, so here, okay, if you see the triangle of V2 here, so it is something like this. So we have a V2 here. So we have another velocity vector of VF2 here and V2 here. So because it is 90-degree triangle here, so means that we could use the equation of V2 square is equal to VF2 square plus V2 V2 square. So I think this equation is quite common for you for triangle. So this is the equation. Okay, we could use the VF here because it is constant. Okay, so it is equal to 2.456, and V2 here is already calculated. Previously, we already calculated that, so it is 5.587. So we could uh, determine the value of V2 square as 37.25 meter square over second square. So now we already have all the parameter here. So what we need to do is we substitute. First, we need to rearrange our Bernoulli equation here. So I think you could do this. So we substitute the value of V1, we substitute the value of V2 and Euler head that we get from the previous calculation. So we get the pressure difference is 3.256. Okay, so here, please be very careful because you need to understand the word pressure difference. What we calculated here is P2 minus P1 over rho G. So we get our answer in terms of meter. So it's called, this is actually the pressure head difference. So this is not the pressure difference. This is the pressure head difference. So the word head here reflect that the unit is meter. Okay, so what you need to do is you need to get the pressure difference. So what we could do is we just bring the rho G here to the right side. So then you will have P2 over P1, and then you will get it is 31,941 Newton per meter square. So Newton per meter square is actually equal to Pascal. So Pascal is a common unit for pressure, but not SI. Fortunately, so the value is still the same because it just converted from Newton per meter square is equal to Pascal. So you just replace the, so it is okay for you not to use this value. Okay, so please make sure that you really understand what is pressure head and what is pressure. So unit for pressure is Pascal, unit of pressure head is meter. So if you see this equation, so this is pressure head, and the equation of P, the symbol of P is pressure. So if P only, so the equation is Pascal or Newton per meter square.